Hey there, JR. Welcome back to Tech 101, the free intro course, and we actually break IT fundamentals in a way that actually makes sense. If you haven't seen part 1 and part 2 yet, I highly recommend to start there. In part 1, we covered IT concepts and terminology. In part 2, we drove into infrastructure and networking and the physical side of things. But now it's time to move to the digital layer, the software that brings all the hardware to life. Now go check those out and let's just jump in. Okay, here we are, Tech 101, part 3, applications, software, and databases. In this video, you're gonna learn today what software actually is, the difference between operating systems, apps, and utilities, what the cloud really means, and how programming and databases fits into everything we use daily, okay? So let's go. What is software? So if hardware is the body of technology, software is the brain and nervous system of it. It tells the hardware pretty much what to do. At its simplest, software is a set of instructions written by people translated into code that hardware can execute. Every click, swipe, and tap that you make, that's the software responding to your command. And here's something really important. Software isn't just apps. It exists in layers, and each one of them have a different or a specific purpose. So let's just start with the foundation here. So the operating system. Your operating systems, or OS, is the master program that manages everything on your device. It's what allows applications to run, files to be saved, and hardware to work together. Just think like the manager of a busy restaurant, right? The hardware is the kitchen, the apps are dishes being served, and the OS keeps everything running smoothly behind the scenes. Some common operating systems you probably use include the Windows. It's pretty much to go in a lot of places use Windows and business environments, right? macOS is pretty much the Apple operating system. Linux is an open source, highly customizable system. And mobile OS like the Android and the iOS, which is the Apple one, that power your phones, tablets, and mobile devices, right? So now each OS handle 4 main jobs: managing hardware resources like CPU, memory, storage, and providing user interface. It's pretty much what you see on the screen, running applications, and just pretty much keeping everything stable. Without OS, your computer just be a box of parts with no coordination, pretty much. So type of software, okay? Let's go. Now that we just understood or kind of know a little bit about that OS, right? Let's talk about these categories here. The 3 main types you'll encounter. So application software, programs that you actually use. Some example can be Microsoft Word, a web browser, a music player, and pretty much helps you complete a specific task. You have system software. They support the OS and hardware directly. Some example can be the drivers, background services, some of the utilities that handle the performance of your computer. You rarely see it, but they're the ones that keep your system stable. Then we got over here development software, tools programmers use to create new apps. We can have code editors, compilers, and frameworks like Visual Studio Code or Python. Pretty much these are the things that some of the developers use to just create. So in short, system software runs the machine, application software helps the user, and development software builds the future. Now in part 1 and 2, we discuss and talk a little bit about the cloud, but over here, let's take a closer look at how software and the infrastructure actually live in the cloud. Instead of installing programs directly on your computer, the cloud computer lets you use applications and store your data online. That makes tools like Google Docs, Microsoft 365, Canva work anywhere, right? You can use all these things from any device from anywhere in the world, right? So there are 3 main cloud service models out there. We got the SaaS, or software as a service, and it's just uses a software hosted by someone else. You got the PaaS, platform as a service. They use developers use this to get an environment and they can build and deploy apps. You got infrastructure as a service. They're virtual servers and storage that you can rent from a provider like AWS, Azure. And so when you save a file in Google Drive, you actually just sending that data to a data center somewhere and not going to your laptop. So that's the cloud. Cloud computing changed everything about IT infrastructure, and it made technology scalable, global, and collaborative. You can just go everywhere and access from anywhere. So let's move on to the next part. So we have introduction to programming. So what builds all this software? And that's where actually programming comes in. Programming is the process of writing code, logical instructions that tell your computer what to do. Every app, website, or game you ever used started with code. Here's a simple way to think about it. Programming languages equals human languages for computers. The syntax are some grammar rules, and then the logic is the thought process behind solving problems. So remember part 1 that we talk about zeros and one, on and off, and the language on computers? So every programming language that you see today, from Python to C++, eventually gets translated to binary language, those zeros and one that we talk about. You write code in human-friendly form, and then the compiler or the interpreter converts into zeros and one, and then the hardware understands what's going on. So when you're coding, you're really giving high-level instructions that become pure binary signals inside the processor. So popular language that you'll hear about include Python. It's great for beginners, data, cybersecurity, scripting, JavaScript. Pretty much it powers the web. It's everywhere. C++, used for operating systems and for some games. Even if you never become a full-time developer, understanding basic coding logic makes you a stronger IT professional, in my opinion. It teaches you structured thinking, the same skills you kind of use to troubleshoot and solve problems in tech. Now let's move on and talk about databases, where all this information lives. A database is a structured way to store and manage data so it can easily be accessed, updated, or analyzed. Think of it like a super organized digital filing cabinet. There are 2 main types of data that you should know. We got a SQL database, use tables with rows, columns, best for structured data. You got the NoSQL database, is store unstructured or flexible data. And I have some examples here of what that looks like. And then right here, you can see there's some of the SQL commands that you can use, like select from user, where department. You know, whenever you're trying to see who works in the IT department, that's a command that you will run in SQL. Database powers everything: your bank app, YouTube recommendations, even your social feed. Now let's go. So how it all connects, right? So hardware is the foundation. The operating system manages the hardware. The application run on top of the OS. The database actually stores the data of those apps, and programming ties everything together. Everything in tech stacks on something else, pretty much. So understanding these layers helps you see the big picture on how systems work. Awesome work getting this far. So now you understand the essential of software, cloud, and databases, the digital heartbeat of every system you'll ever use. And like the other videos, head to the pinned comments, and you're gonna have your 10-question challenge quiz to see how you doing. Same as before, answer and I will give you feedback. Now I have a discussion question for today. What is one piece of software that you can't live without? And tell me why. Now coming up next in Tech 101, we got part 4. The last part is security fundamentals. We'll explore how cybersecurity actually works, the most common threats, and how to protect yourself and data. Now, if you're enjoying the series, you know what to do below. And thank you for watching. We'll see you on the next one. JR out.